So welcome guys to a new video, and in this video I am going to try to solve a problem that I am currently having right now, which is actually I am making homemade yeast. So to form yeast we have to do a small recipe, and that recipe needs to be a constant temperature for about 13 to 14 hours, or maybe maximum of 24 hours. So we have to maintain a constant temperature. So as a tech guy, so what I have decided, I would be using a Arduino and a DHT 11 sensor to measure the temperature, which is for this recipe is about 32 degree to 35 degree. So what I have done is I have wrote a code. uh, uh, I will put the code in the description so that you can copy it. So what I have done is I have set it a fixed temperature swing. So you can see constant temperature, that threshold is 33 degree, and temperature off is 35. So the temperature stays between this area. So that would allow us to actually put a hysteresis, so that the relay does not like oscillate if temperature goes a bit down. So if we set this whole temperature thing to a constant temperature, so the relay might oscillate to reach the constant temperature, because the temperature does not hold, it leaks. So it might go into oscillation. So that is why I have decided to put it 33 to 35 degree. That's good enough for the recipe. So I will show you the recipe after I complete this test. And here I have used Arduino Uno, you can see, and DHT11 sensor has 3 pins. One is positive, one is negative, and another pin is the data pin, and I have connected this to a analog 0. And at the output you can see I have soldered 2 wires, and there is a relay, and there you can see uh, a diode, that is a flyback diode connected across the relay. And there is a BC547 and a 1k resistance, and here you can see a 100 ohms resistance. So that completes the circuit, and that is connected to a pin number 13, which is also this LED. So we will see this in action. I have also put a print option, so that let me focus my camera, so that you can see what this whole thing is actually doing. You can see right now it is measuring temperature. Right now it says 21 degrees Celsius. So if I put my soldering iron near the temperature sensor, and if I hold this sensor above this area, we should be seeing temperature rise, and slowly, like you can see 22 degree, 23 degree, you can see the temperature actually rising, and the light over here is actually on. So that is indicating our system is currently on, the heater element is currently on. And we can see we have reached 32 degree, 33 degrees Celsius, and we should be, yes, you can see our temperature is actually off. So it also says heater off, and the temperature keep rising. If I put this away and let the sensor cool down a bit, and let me blow some air across it so that it cools down. You can see temperature is falling down, 41, 40. So this soldering iron is actually getting hot. So you can see 36, 35, 34, and here about to reach 33, and it should, yes, there you can see it turns on. So we are going to use this feedback system to heat our uh, oven. So let us see the oven contraption. I will put the code in the description so that you can copy it, and the connection is quite simple. I will draw a circuit diagram, discrete circuit diagram, to illustrate this relay connection. It's quite easy if you know what you are doing, so it's easy. So very simple, and you just make sure your Arduino IDE contains the library, and I will you can directly download it from Adafruit, or you just go there, the library option. After going library, you just have to search DHT 11, and the library that is from Adafruit, you have to download the Adafruit library, that one, DHT sensor library by Adafruit. So you have to install this library. I have included bunch more libraries, so that that might not be the issue, cannot be the issue, I think. But if you didn't find the library in the ID, you can directly go to the Adafruit sensor.h directly from the Adafruit website, and you can add this to your ID by the zip format. So you just have to go to the sketch, include library, and there you can see the add zip library. So you have to include the zip library so that you can operate it. So I will you can install it very easily. So I will show you the contraption actually. So over here we have some clothing to keep the oven warm, and if I remove the cloth and bunch of heating system, you can see our there is the fermented solution that is sitting over here. And if I try to open this, you can see CO2 formation had happened, and the fermentation is actually working. And underneath that, this is a ceramic type material that is used in power electronics. So it's quite ceramic, so it can absorb the high temperature rise so that the plastic does not get melted. And there is 200-watt bulb that is sitting in a aluminum bowl, a disc reflector, whatever you wanna call this. So this actually radiates heat, and we put this across here so that it does not get directly melt our plastic, and the whole thing sits top of this, and the whole oven system is covered with cloth. So we will wire this, and I will show you what it might look like from the outside, so stay tuned. So I have actually connected the system to the system. As you can see, the light bulb is actually glowing, and the light bulb is supplied with 220 AC, and we have to careful around this section, because although the relay circuit is isolated, but we have to make sure. You can see temperature has been reached and the filament is actually off, and there you can see the filament is off. And I will show you the circuit diagram. And in the circuit you can see a microcontroller that is Arduino, our Arduino, and this is the relay, and this is the heating filament, that is the 200-watt bulb that you have just seen, and that is being supplied by AC. And here is the relay, that there is the feedback diode, feedback fly freewheeling diode, whatever you want to call, that suppresses the high peak currents that might be harmful for your transistors or microcontrollers. And here is the DHT 11. We have to supply this with 5-volt supply, and the ground is has have to be connected to the microcontroller, as well as this sync ground is also have to be connected with the microcontroller, so that the incoming signal, incoming current have to flow through this 1k resistance, through this emitter, and through this 100 ohm resistance, and through back to the microcontroller, so that this circuit completes, so that this 12 volt supply can get the current flow from the positive 12 volt through the relay and goes to the ground. You can use separate supply, or you can directly connect the 12 volt supply to the input of the Arduino or whatever microcontroller that you are using, and ground have to be common, and you have to make sure the connection, the AC connection part, has a fair bit of distance and isolation from your control DC part, because that may lead to damage some equipment. And you can see our temperature probe is actually working, and right now the filament is off because the temperature inside the system is actually remaining high. So if I open the top and cool the system, the heating system might turn on. So you have to leak some hot air inside them. If we cool the system by whatever, so this is actually working, and yeah, so we have run into some issues because our 200 watt system is actually a bit overkill for this purpose. So we are switching this system to a 100 watt system with a single 100 watt bulb. So we are currently replacing this 2 bulb which is hot right now, and that is being replaced with this simple single 100 watt bulb. And here we have a digital temperature for measurement of accurate temperature, and this sensor goes over there. We are just observing what is the internal temperature. So we have observed that it is being reached 42 degree, and it's still not coming back down. So it might be unhealthy for the bacteria. So we just compromise this, and we decided to use a 100 watt bulb. Let's see how this one performs. So there you can see temperature is below the threshold. That is why the filament is actually on, because the pin number 13, the internal built-in LED, is actually glowing. That means the signal is actually turning on this relay, but we are not connected to anything. So there you can see we have placed the sensor inside, and we are covering this whole system. And just for a good measure, we have to put this sensor inside so that we can monitor this externally, because I don't have an extra computer to monitor the system activity. So there you can see 24, 25, that is the current temperature. And if I plug in this supposed to turn on the LED, the internal temperature says it is 29 degree, and if I turn on this system, that you can see the light is glowing, temperature is actually rising, and heating system is on. So let's see it cut off at 33 degree. Filament is still glowing, and anytime, so we should see the system turning off. So that's it for this video, and we will see you guys in the next video.